Welcome back, ladies and gentlemen, guys and gals, and we're going to continue our review of the atomic structure, and now we're going to be talking about ions. What are ions? I'm glad you asked that wonderful, fabulous question. Ions are elements or atoms that have a positive or negative charge as a result of gaining or losing an electron. So all elements want to be stable. That means they want to be happy. In order for them to be happy, they have to satisfy what we know as the octet rule. And the octet rule is where most elements tend to want to have 8 valence electrons, aside from hydrogen and helium and a couple other elements. So let's go ahead and take a look at how elements are able to satisfy that octet rule with ions. Now, the ions that we're going to work today with we're going to be working with sodium, and we're going to be working with chlorine. Now, sodium and chlorine come together to form an ionic bond. How do we know they form an ionic bond? Because it's a bond between a metal and a non-metal. Sodium is a metal and chlorine is a non-metal. So if we look at sodium on the periodic table, we notice that sodium has 11 protons. It has 12 neutrons in the nucleus, but we're going to focus on, if it has 11 protons, then it's also going to have 11 electrons. So now we're going to draw an atomic Bohr model, and we're going to show the number of electrons it has in each ring. On this first ring, sodium can only fit 2 electrons. On this second ring, sodium can fit up to 8 electrons. So let's go to work and put our 8 electrons on here. Now, since it has to have 11 protons and 11 electrons, let's count up our number of electrons so far. We have 2 on that first ring, we have 8 on that second ring, which gives us 2 plus 8 is 10. So that means we need 1 more valence electron. So we put that last valence electron up there, so that gives us 11 protons and 11 electrons. So now let's look over at chlorine. Chlorine has 17 protons, so it's also going to need 17 electrons. So 2 on this first ring. We can fit up to 8 on the second ring. So let's go ahead and go to work. And then on this third ring, we're going to put 7 valence electrons. Why? Because we have 2 on this first ring plus 8 on the second ring, which is 10, plus another 7 is going to give us 17 electrons, which is going to match up with our number of protons. So I put my electrons here. Now, in order to satisfy the octet rule, each one of these elements wants to have 8 valence electrons. So the question is it easier for sodium to give up 1 valence electron or take in 7 valence electrons? You guessed it, it's easier for sodium to give this 1 valence electron to chlorine. So that's exactly what it's going to do. So now, when sodium gives this 1 valence electron to chlorine, look what happens. Instead of chlorine having 17 protons and 17 electrons, now chlorine has 17 protons and 18 electrons. When we subtract these two, it gives chlorine a -1 charge. A -1 charge. Why is it a -1 charge? Because there's 1 more electron than protons, and electrons have a negative charge. Now let's look over here at sodium. Sodium has given away one of its electrons, so now sodium has 11 protons and it has 10 electrons. So if we do the math on it, 11 minus 10, that gives us a +1 charge. Why is it +1? Because protons are positive, and there is 1 more positive charge than negative charge. So that's what an ion is. It's an element or an atom that has a positive or negative charge based on the number of valence electrons it has. And ladies and gentlemen, I hope this tutorial was helpful. I am Spivey signing off, and this is my son,
Jordan Spivey.
and ladies and gentlemen, y'all have a great day.